There we go. So welcome everybody to the Robert Ferguson Observatory Speaker Series. My name is Stephanie DeRomalar, and I'm the Executive Director for the Observatory. We're so thrilled and honored to have Dr. Ed Liu with us today, and I'm going to introduce him in a moment. But before we start, just want to remind everybody to please keep yourselves muted to minimize background noise, and we'll we'll have some time for questions at the end. You can feel free to put them in the chat as you think of them, and I'll help facilitate that at the end once Dr. Liu is done with his presentation. And for those of you who are not familiar with the Robert Ferguson Observatory, we are run by the Valley of the Moon Observatory Association, which is a 501(c) nonprofit comprised of volunteer, amateur, and professional astronomers. RFO has fulfilled its mission of offering educational programs about science and astronomy for students, the public, and in support of educators for about 25 years now. We are almost all volunteer run and typically serve about 9,000 visitors annually. And the observatory is located in Sugarloaf Ridge State Park, which is in Kenwood in Sonoma County. The observatory houses a 40-inch reflector telescope, which is the largest telescope in Northern California that's accessible to the public, a robotic 20-inch research grade or CCD telescope, and an 8-inch 2-meter long refractor telescope. We truly are a public, oops, sorry, letting more people in. We're truly a public observatory, which means that anybody from the public can come and volunteer with us and learn how to operate our scopes. So it's, as you can imagine, a very unique and special opportunity for really the community and obviously a lot of students in our area as well. Volunteering is a great way to get involved in the observatory. If you are so interested, we have a volunteer application on our website, rfo.org. Membership is another great way to support the observatory and get some fun membership benefits along with that, which is also outlined on our website. And lastly, we've kept these presentations in our speaker series free to the public to align with our mission of offering educational-based astronomy programs to our community. That being said, if anyone is so inspired to donate to the Robert Ferguson Observatory to ensure that we can continue fulfilling that mission, you can also do so through our website at rfo.org. So now for the part that you all came here for, wanted to introduce Dr. Ed Liu, who, by the way, was just racing through the rain to get here on time. So thank you, Dr. Liu. Dr. Liu is the Executive Director of the Asteroid Institute, a program of the B612 Foundation. Dr. Liu served as a NASA astronaut for 12 years. Sorry, letting another person in. He flew aboard the space shuttle twice and flew on the Russian Soyuz to the International Space Station, where he did a 6-month tour. He has logged over 206 days in space. Dr. Liu has been an active research scientist in solar physics, astrophysics, plasma physics, cosmology, and planetary science. He held positions at the High Altitude Observatory, the Joint Institute for Laboratory Astrophysics, and the Institute for Astronomy. At Google, he led the Advanced Projects Group, which built imaging and data gathering systems for Google Earth and Maps, Google Street View, and I think somebody needs to mute themselves. And Google Books. He is also a co-founder of Leo Labs, a startup building and operating a network of ground-based phased array radars for tracking satellites and space debris in low Earth orbit. Ed is also the co-inventor of the Gravity Tractor, a controllable means of changing the trajectory of an asteroid. So we are so honored and thrilled to have him with us here today. And without further ado, Dr. Liu, I will pass it on to you.
Well, thank you so much, and thanks everybody for joining us on this rainy Thursday evening. And it's a real pleasure to get to speak to you tonight. I want to tell you about some of the work that we've been doing at the B612 Foundation's Asteroid Institute and why I think it's so important. So, but first I wanted to show off my ugly sweater. So, because it brings together, one of the things that I was always fascinated with as a kid, which is dinosaurs. And dinosaurs, of course, leads us to asteroids, and perhaps we can talk about that at some point. But let me first share my screen and we'll get started. Okay, hopefully that is visible to you.
It looks great.
So let me move my screen up here so I get out of the way. And so let's talk about the intersection of dinosaurs, the Earth. Why is it doing that? Okay, did it come back? For some reason, my screen shifted on me.
Yes.
Are you still seeing it?
Yes, we see the main
Okay,
slide.
great. So the intersection of space, asteroids, dinosaurs, and maps. So let's get started. So first, I wanted to start with a photo from my old office window on board the space station. And it's a picture I really like of the Great Lakes. Now, if you kind of tilt your head sideways and look to the upper left, that's north. And I think you can see my cursor. You see the circle that I've drawn right here? This is an interesting spot on planet Earth. So we're looking at Lake Erie here, Lake Ontario, Lake Michigan down here, and so on. So this up here is in Canada, and it is the town of Sudbury, Ontario, which is an interesting place. It is the site of the world's richest iron and nickel mines. And in fact, there are quite a number of mines there. And in fact, when the Dow Industrial Average, which is the group of 30 companies that comprise it, the original group of 30 Dow Industrial companies included a company called INCO, which was the International Nickel and Copper, I believe it is, company, because it was situated here, and it is, it was one of the largest companies in the world at the time, roughly a little more than 100 years ago. The question is, why is there so much iron and nickel here? Well, it turns out that about a couple 100 million years ago, a large asteroid landed here on Earth, very large, and it was made of iron and nickel. All that iron and nickel ended up in the ground over hundreds of square miles here, and that's the source of those mines. So in some ways, actually, the economic history of the Earth has been influenced by asteroids. This is the first way. The next way that asteroids have influenced the history of Earth is that sometimes they hit Earth with bad consequences. So this is a photograph taken from a dashboard camera in the city of Chelyabinsk, Russia, at about sometime early in the morning in 2013. And what you're seeing here is an asteroid entering the atmosphere above the city, going over the top of the city and exploding on its way out of town, as it turns out, about 40 miles above the surface and headed at about Mach 20, between Mach 20 and Mach 40 when it exploded. So going extremely fast. The energy released by this explosion in the atmosphere was about 30 times larger than the bomb dropped over Hiroshima. So it's about 30 of those exploding at once. Luckily, it was, a good 50 to 100 miles away from the city. But because of that distance, the shock wave went mostly over the city. And that's the reason we did not have 1 million casualties that day. As it was, it put about 1,500 people into the hospital, collapsed a number of buildings, broke essentially every piece of glass in the city, and quite a large explosion. So this sort of thing happens every once in a while, and it's actually not surprising that it happens because almost all of the asteroids in orbit around the sun are currently untracked. And so the way that actually NASA found out about this explosion is on Twitter. People started reporting an enormous explosion on Twitter. That's how they found out about it. Okay, and that's not uncommon. In fact, most of the asteroids that hit the Earth arrive unannounced because the vast majority of asteroids are untracked. So this was a small one. If anyone wanted to guess, it's probably smaller than most of you would have guessed. It was only about 19 meters across. So the size of a small building, but like I said, moving extremely fast. So let's talk about mapping. Now, how does all relate to mapping? And what does this mean when I say the opening of frontiers? Well, I'm going to posit for you that the three main motivations for human beings to engage in mapping, in the mapping of frontiers, can be summed up as fear, greed, and curiosity. And in fact, I'll argue that that mapping is actually the key to opening of frontiers for these three reasons. Well, what do I mean by that? So let's take a stroll back in history. This is a really interesting map. It was discovered. It was a map produced in about 1504, 05, something like that. It's a little bit uncertain, but around that time, Columbus had just been to the New World just less than a decade earlier, or about a decade earlier, and the great powers at the time, the Dutch, the French, the Spanish, the English, the Portuguese, were all engaged in a race to map the New World, the world itself, right? Now, why were they spending all that money and great treasure to send these expeditions out to map things? So I'm going to posit fear, greed, and curiosity, right? Well, one of their reasons is they're looking for trade routes. Okay, remember Columbus was trying to get to actually Asia by heading that direction, and you can see that within a few years, actually, the maps have already gotten fairly detailed. They got Africa mostly right. They got India correct. They got this is Florida, as it turns out. They got parts of the Caribbean right and parts of South America right. It's rather amazing how far they've gotten in just a few short years. But they're looking for trade routes, right? So this is a bit. I'll put that under a heading of greed, but really it's a chance to exchange goods. In fact, the basis of the first international corporation, which was the Dutch East India Company, was mapping. In fact, this is one of their maps. Now, their maps are actually not that commonplace anymore because they were their trade secret. That was the secret to success of the Dutch East India Company, which was the world's largest corporation for nearly 200 years, which is fairly amazing. And the thing that they had over everybody else is that they had the world's best maps, which they made, which allowed them to navigate from place to place, and they knew where the harbors were and so on. They knew where the points were, the place where you could navigate from, and that was really what. In fact, if you look over here, you'll see that they actually required their captains to sign out a map when they took it on a journey and to sign it back in, so that these charts were extremely important. They understood the value of mapping, again, for the purposes of trade. Here's a map that's interesting. It's the map of the New World created by Lewis and Clark. So they were sent on what was called the expedition of discovery. It was right after the purchase of the Louisiana Purchase, and they were sent to map the flora, fauna, navigable trade routes, and points of defense. And this is one of their original maps that they drew. In fact, I would argue that whenever you have any new frontier, the key to all the opening up of those frontiers is maps. So even sort of virtual frontiers like the frontier of genomics was enabled in the 1990s, early 2000s by the mapping of the human genome, right? So again, fear, greed, and curiosity, right? So fear can be summed up as the points of defense. How do I defend this territory, right? Greed, well, that's the opportunity for commerce. And curiosity, well, that's for the science of what's out there, right? So Lewis and Clark, they were told to, map points of defense, trade routes, and bring back samples of plants and animals. So fear, greed, and curiosity. The human genome, why did we map it? Because fear, greed, and curiosity. Fear, well, it's the opportunity to learn how to protect ourselves from genetic diseases. So in some sense, it's a defense, right? Greed, well, there's a lot of money to be made in curing people of these diseases. And curiosity, because the history of humanity is written in its genetic code. So what's the next great frontier? Well, I'd argue that the next great frontier is space. People have been saying this for a while, but it's really interesting to see a graph of what's going on in space. So if you look down at the right-hand side, this is a graph of the total number of spacecraft launched. So starting at the beginning of the space age in the late 50s to 2018, okay? There is a more recent version of this graph, which we're working on right now, but it's broken up into commercial, private, which is the screen, and then the various countries. So for many, many decades, the number of spacecraft launched per year was fairly constant at around, between 100 and 150. And then starting around 2013 or so, it started to decline. In fact, in 2018, it got to 350. 2019 was around 900. 2020 was about 1,500. 2021, 2,000. 2022 is going to be well over 3,000. So it's past the top of the graph, okay? And nearly every satellite today, more than 95%, are private. They're commercial satellites nowadays. It's gone from being governments to commercial. Okay, so the space frontier is opening up. If you want to look at it in investment dollars, this is a study from Morgan Stanley, but there's a similar one from Goldman Sachs. There's a similar one from the Space Foundation, and so on. And they all say that if you treated space as its own country and measured its GDP, its gross domestic product, the value of goods and services there, it's going to pass $1 trillion here sometime in the next couple of years, and it's growing ridiculously fast, roughly 10% a year or so, which is roughly similar to the growth rate of China over the last 2 decades. Okay, and for anyone who has ever been to China in the 1990s, when people, where Beijing was a sea of bikes, to what it looks like today, that's the difference a 10% growth rate makes over a couple decades. Right? It's the power of compound interest. And we're seeing the same story in space right now. So I would argue that space itself is going to be an enormously large part of the world's economy. Much of the world's economy will not be on the surface of the Earth in some number of decades, not centuries, but decades. And I mean, this is really a frontier, right? So what are the keys to opening up of the space frontier? Well, I think just like everything else, it's going to be mapping. I just like this picture. It's a picture that it's Elon Musk's car that he launched on the first of the Falcon Heavy launch vehicles. So what do I mean by the space frontier will be enabled by mapping? So first off, let's look at the asteroids in our solar system. Remember I mentioned that most of the asteroids which hit the Earth are untracked. Well, there's about 1 million asteroids or so that are sort of significant size in the solar system. And of those, about 3% of them are mapped. So what that means is if you drew a map of the solar system, what you would find is that only about 3% of that map is actually on the map. So I'm having trouble playing this. Here we go. And we're having a problem. Why is it not working? Okay. Here are all the known asteroids in our solar system. This is the orbit of the Earth, Venus, Mercury. This is the asteroid belt. Sorry about I don't know what's going on with why this is plugging up, but in any case, I think you get a feel for there's a lot of asteroids out there. In fact, almost everything in the solar system is actually an asteroid. Almost all the world, each one of these is its own little world. And the point is that only about 3% of what you're seeing here is about 3% of the total. Okay, so 90+% of the asteroids are not on this map. And what that means is if you drew a map of the solar system as it is today, almost everything is missing. So that's where we are right now. So why would we want to map this new frontier? Well, let's start with the curiosity. Well, science. Well, it turns out the distribution where all these asteroids are and what their orbits are is actually the record of the history of both Earth and all the planets and the formation of our solar system. Where did the Earth come from? How did it evolve? The history of that is written in the map of the locations and trajectories of all these asteroids. So if you could understand that, you can understand sort of how the planets have moved, how their orbits have changed throughout the life of the solar system. So we have a strong incentive, just from a pure science standpoint, to know where all the asteroids are. And again, when I say all the asteroids, that's essentially the map of the solar system, because almost everything is an asteroid in our solar system. Here's a cool picture of an actual asteroid taken by a Japanese spacecraft. And obviously, if you had a map of where all these things are, you could send probes out to see these things. Every one of these things is a world. This is about half a kilometer across. So this is a small one, but there's millions of these. Okay, let's talk about, let's go to the greed component of it, which is kind of a crass term, but it's essentially commerce, right? So remembering that every object in our solar system is actually moving, the Earth is moving around the sun, the asteroids are moving around the sun, everything is moving. The key to navigating the solar system is to know where all these things are and where they're going. And I would posit that the basis of all commerce is at some level driven, enabled by having maps of where you're going. You have to be able to navigate things. You also need to know where all the resources are. So there's an interesting book called The High Frontier, written by a very influential professor at Princeton called Jerry O'Neill. And he talked about the colonization. He was sort of the first person in the 1970s to realize that most of the raw materials, the metals, the accessible both energy sources and materials throughout the solar system are actually located in space. Vast majority of them, far larger than what's available on Earth. And if you ask yourself, what he realizes is that as human population grows, at some point you cannot support a larger and larger population on planet Earth because of the limitations on both energy and resources. And so he argued that at some point human beings need to move outwards into space. This is a map. It's kind of a fun one. It's the Permian Basin. So this is actually New Mexico and West Texas. It's a map of all the oil claims. So these types of maps are very, very important because it allows companies or individuals to lay a claim when they discover a resource. And the basis of all those claims is this map. And that's what allows them to invest money into pulling resources out so that they can develop these resources. This is where all the oil and all the most of the energy in the world is coming from. This is where all of the metals that produce our electronics, our cars, our buildings, our entire society is built on mining claims maps like these. And the same will be true in space. But again, in space, though, you have to think about the fact that everything is moving. Finally, remember we talked a little bit about that asteroid that blew up over the Russian city of Chelyabinsk. Those hit the Earth about every few decades, which is why we saw one, less than 10 years ago. But larger ones sometimes hit the Earth. In fact, the one that is commonly known about is the one that killed off the dinosaurs. That was very large. That nearly sterilized the Earth. Roughly 90% of all species on Earth went extinct that day. Most people think that when that asteroid hit, it was a long, slow, drawn-out thing. No, most things died that day. It's a matter of hours. The timeline is, but that was a very large asteroid and a very rare occurrence. Only about every 50 to 100 million years does something that large hit the Earth. Although if you look at the age of the Earth being around 5 billion years old, you realize that, the Earth has been hit by large asteroids like this tens to hundreds of times. And in fact, in the fossil record, there are tens to hundreds of mass extinctions seen. We don't know what caused them, but it actually matches up pretty well to the number of large asteroids that have hit the Earth. So every once in a while, life on this planet nearly goes extinct and it regrows into something else. In fact, the reason that we human beings are really here is because the asteroid wiped out the dinosaurs and the dinosaurs went extinct. So in some sense, our job here is to try and not be the previous civilization that some other civilization which takes over after us, because we didn't do our job of protecting the Earth. So that's what we formed the B612 Foundation to do, because it turns out that in order to protect the Earth, the very first thing you need to do is know where all the asteroids are, because you need to know if one is going to hit the Earth so you can do something about it. This is the asteroid that hit in Tunguska in 1908, and I've drawn a ring around it showing the size of the destruction area, but you can see that it's larger than most, typical large cities. These things hit the Earth every few hundred years, and this one had impact energy of about 10 megatons, which is quite large, larger than the largest of the current nuclear weapons. So it turns out that if we knew in advance that an asteroid was going to hit the Earth, that we can actually deflect it. And the first actual demonstration of that was just about 3 months ago, when the DART mission flown by NASA deflected a small asteroid by a tiny, tiny, tiny amount, but enough to make it miss the Earth, had it been done about 10 years before that thing was going to hit the Earth. So the secret, of course, then to protecting the Earth is to find an asteroid 10 years before it hits the Earth. Okay. What does that mean? If I knew where every asteroid was and where it was going, then I would know if any of them was on a collision trajectory with Earth. So if I had this map, I can develop space, I can protect the Earth, and I can understand the history of the Earth. So that's the motivation for building the space map. So how do you build it? Well, it starts with observatories. Now you folks at the Ferguson Observatory have some neat ones, but there are some larger ones out there. I'm showing here the Pan-STARRS Observatory in Hawaii, one of the most prolific observatories for finding and tracking asteroids. But again, thus far, we've discovered with observatories like this, about 3% of the asteroids that could hit the Earth. Okay. The world's largest observatory for finding and tracking asteroids is under construction. This is a photograph of it taken about a year and a half ago. This dome is now complete. The main mirror is now in. The main camera is on its way down there in the next few months. This observatory, called the Vera Rubin Observatory, which is being built in Chile at the cost of about $750 million, paid for by the National Science Foundation and the Department of Energy. It's an American-led project, but there's about 50 universities involved. This telescope will find and track more asteroids than all other observatories combined when it opens its dome, which is in about 2 years. And there's even interesting ways of taking telescopes to space, things that we're working on here on the lower right. It turns out this is we can talk about this later, but there's even ways to do better than this observatory here, the Vera Rubin Observatory. So if you're going to map space, you need observatories, and what you generate with observatories is images of the sky. But what really is a map nowadays? Think about what most people think of as a map is actually, what's on their cell phone, right? They go on their map, they use Google Maps or Apple Maps or whatever. And what makes a modern map now is it's not like the older maps, which were a static piece, something written on a piece of paper. A map nowadays is really a combination of data, those images taken by telescopes, and services. What do I mean by service? Things that allow you to calculate things on the map and to share the data that's on the map with others, right? Why is Google Maps so powerful? Because anybody can build a business on it. So here's some example of companies that rather than building their own map, they use Google Maps in order to bootstrap their company. Zillow, Uber, Lyft, quite a number of other, real estate, you name it. They have been able to use Google services together with the Google Map data to build location-based services. And I believe that location-based services is going to be the key to the economic development of space. So what does all that really mean? That means you need to get a lot of telescopes or large telescopes, gather their data into one location, and build services. What does services really mean in terms of that? It means the calculations of trajectories in space. The term for that is astrodynamics, and what we at the B612 Foundation are really doing as we search for asteroids that could hit the Earth is we're actually helping build this space map by building these services and gathering the data from various telescopes. So in some sense, what we're doing is we've got a sort of our mission to protect the Earth is actually larger than that, which is actually to map space. And as a side benefit, you get to protect the Earth. So, how are we doing? So these services, one of which is actually discovering asteroids, is something that we've gotten quite good at. This is a New York Times article describing our work just from earlier this year with support from Google Cloud, and we have been able to combine these telescopic images from various telescopes together with cloud-based services, and we're turning it into that space map. It's going to be a much better space map when that Vera Rubin Observatory turns on. And in fact, we're part of that project right now to take advantage of all that data coming off of that. It's going to be an interesting observatory. About 4 petabytes per night of data is coming down off the mountaintop. It's going to be a real challenge to just manage that data set. So what do you get when you put all this together? You build this map. Where are all the asteroids and where are they going? So this is what we're building, and with this, you'll be able to. I think we'll be able. This is going to be one of the keys to opening up the space frontier. Like I said, understanding where, the history of the Earth, and as well as protecting the Earth. This is actually a more recent picture of that dome that I showed you. So, like I said, it's opening it up soon, and that's what we're preparing for right now. So I did have to put in a plug. Just like you are, we are also a nonprofit. We have to pay a number of software engineers. We have a team of a handful, under 5 engineers, and a whole bunch of volunteers. But we do have to pay those folks. The last line of that New York Times article was fun, because what we told them, we said, we're the answer to a trivia question now, which is, how is vodka related to asteroids? Well, it turns out one of our major supporters is actually a vodka company, Tito's, and they have donated $1 million to us, but as a challenge grant, meaning anybody who donates to up to the next $1 million, they'll match, and this is how we pay our engineers. So I'd like to thank them and put a plea out to all of you. If this is something that you find interesting or exciting, or if you want to do something that's in the long term beneficial to humanity, well, then I think we're doing something quite interesting. And so if you have any, if you would like to know more, please contact us. We have a lot of supporters, thousands of supporters around the world. These are some of them, but like I said, there's some very major ones too, including Tito's. So I'll end it there, and happy to take any questions on anything.
Thank you so much, Dr. Liu. And I think there was already a question in here. I think a couple. So the first one was longitude measurable during the, this is more of a historical question. Mm-hmm. Was longitude measurable during the Dutch East India Corporation's dominance in mapping? If not, was it straight reckoning on distances?
No, the Dutch East India spanned, like I said, about 200 years. This is the period at which navigation changed quite considerably with the ability to measure longitudes through precision clocks. So I believe that the kinds of maps they had at the beginning of the corporation, the kind of maps they had at the end were quite different. There was some dead reckoning involved early on, but it's not that accurate. So interesting, yeah. For those who know a little bit about navigation, that's quite an interesting history.
For sure. And then I just wanted to share a comment Kramer made. A book about the asteroid strike is The Last Days of the Dinosaurs by Riley Black. I found it fascinating. So thank you, Kramer, for sharing that. Rebecca asks, what will be the time frame to complete the asteroid map using Vera Rubin?
Well, the Rubin Observatory, we're planning for at least a 10-year run with that. Now, that will not complete the map, not by any means. It probably will get us to about the 10 to 15% point. So, but remember that the larger asteroids are easier to find, so it will help us very much on the larger asteroids. But the smaller ones will be, you can still find them, but it's less efficient at finding them. So it will be far from complete, but way better than we have today.
Perfect. Yeah, better than the 3%.
Yeah, exactly.
Stephen asks, I'm guessing that there aren't nearly enough astronomers to interpret all the data from the VR observatory. Are there computers / supercomputers that will do that data analysis?
That's exactly true. The scale of the data coming off of this machine, this observatory, is so large that these are not things that will be looked at by human beings. The telescope will take about 1,000 images a night. Each image will have on order 5,000 asteroids in it, and it'll be doing this every single night for 10 years at a minimum. Okay, so like I said, it's about. I actually got to see the camera for the telescope, which is here in California, but it's being shipped out fairly soon. It's roughly the size of a small car. Literally, it is the world's largest camera in terms of for folks who know a little bit about camera imaging chips. You know, if you've looked on a really nice professional camera, the imaging chips may be this big. You know, I'm holding my fingers up here. You know, maybe a half inch by a quarter inch, something like that. This one is measured in, it's like 8 feet by 5 feet. And it has 8,000 lines for the data lines coming off of it. Not one, it has 8,000 lines in parallel because it is so big, you can't get the data off fast enough, even at the tremendous speeds this thing operates at. So you're correct. The only real way to do this is to treat it like a big data problem. And that's why I think the work that we're doing is so important, because we are really thinking of it from the beginning like a big data problem. Right. And so, with the help of Google on the compute side, they've been a wonderful sponsor, providing our computing resources and storage resources. This is a tractable problem using that kind of computation, but it isn't the kind of thing that any human being could look at each image. There's too many.
Wow. Perfect. And then Tom asked, does position of the solar system in the galactic plane fluctuate? And if so, could this subject it to increased risk of an asteroid strike?
Yeah. What you're talking about is the fact that the Earth and the sun actually oscillate a little bit through what's called the galactic plane. And that can take objects which are not in the asteroid belt, but much further out, the Oort cloud, which is where comets come from, to disturb their orbit so that some of them end up entering the solar system. And that perhaps has a bearing on the fact that it seems like these large impacts have a bit of a periodicity to them, meaning sort of about every 100 million years or so, it seems to be more likely. That's about the same as the timescale on which our solar system oscillates through the galactic plane. Although this is an absolutely tiny effect, just compared to almost all the asteroid impacts, that's just pure randomness. These asteroid impacts are about 1,000 times more common than these large comets and things from the Oort cloud. So the real issue right now is asteroids, not comets. So I'll solve the comet problem later, once we solve the asteroid problem.
Wow. I mean, it is amazing. That map you shared that only showed 3% is kind of overwhelming to look at, to be honest.
Yeah, of course, remember the asteroids aren't as big as the dots, because if you actually made the dots to scale, you wouldn't be able to see them. So you have to expand them to make them show up on a screen. So you shouldn't get the feeling that it's filling space, but rather you should get the feeling that there's a lot of them.
Yeah, I mean, it's seeing that makes you think it's amazing that that it is relatively rare to get an asteroid hitting Earth. But
Yeah, I mean, something that of the size of a nuclear weapon is only every couple of decades.
wow. Okay, there were a couple other questions. Once we deflect an asteroid, where do we send it to? Wouldn't there be a chance to disturb the Oort cloud if we were to send it any which way?
Actually, when we deflect an asteroid, we're not really changing its trajectory very, very much. We're just nudging it off a little bit. We're typical percentage of, if you think of the velocity of an asteroid around the sun, what we'll end up doing is changing the velocity by something like 1/1,000,000th of 1%, which is really small. So it's not going to start going out in, far, far away. It's going to look almost unchanged, but it won't hit the Earth. And the reason is because the Earth's a moving target. You have to be in the same place at the same time as the Earth. So if you can just make the timing a little bit different, so it'll still go through that intersection where the Earth was, meaning that asteroid is still a danger to the Earth at a different date, but at least on that date, it's not hitting it. So it doesn't send it far, far away. It just makes it such the Earth, which is driving through an intersection, and the asteroid, which is going through the intersection, also, they're not there at the same time.
Got it. Oh, right. How often do asteroids collide with each other, and can the new trajectories be predicted, or do they have to be found again?
They sometimes collide with each other, but it's pretty darn rare. The real way that asteroids change their trajectories is because they get close to planets. Jupiter, Mars, Earth even, and the gravity of the planets is what changes their trajectory. Far, 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 far bigger effect. And that is something that is possible to calculate, but tough to calculate accurately in every case. We can do pretty well for the Earth, because if it comes close enough to the Earth, we actually can see it really well. But if it's coming close to Jupiter, it's a little tough to track. So you do, once you build a map, you have to maintain the map, right? So you actually have to continue to track things bit by bit to make sure that it's kept up to date. In the same way that if I had a map of all the streets in the United States, and 10 years, it's not a very good map anymore.
Right.
Yeah.
And even more so because they're moving all the time. I mean, I can't even imagine.
Yep, but they're moving on trajectories that we understand.
That's the good part.
The power of math, right?
You're right. Barbara had a question. How big is a quote big asteroid? Bigger than Earth's diameter, or what constitutes a big?
Oh no, a big asteroid, the kind that would sterilize the Earth, might be only 10 miles across.
Wow.
So one that would wipe out human civilization is probably about a half a mile across. That would wipe out human civilization everywhere on Earth. One that could wipe out a continent might be a few hundred meters across. One that would destroy, say, Northern California might be 150 meters across, would fit inside a football stadium.
Wow.
So they're not as big as you think.
And
so when you hear, oh, go ahead.
I imagine they also move at different speeds, right?
No, yeah, well, yeah, but all of the speeds are fast. Like the slowest any one of these things is moving is about 30,000 miles an hour.
Wow. Wow.
So that's what makes the energy so big.
Okay.
One way to think about it is as a kilometer-sized asteroid hitting the Earth has the energy of a few billion nuclear weapons.
Oh my gosh.
Okay, so the way to think about that is there's about a 500 million square kilometers on Earth. Okay, if you cover the whole Earth, right? That means if I place the nuclear weapon every square kilometer, so 3,000 feet away, I put another one, another 3,000 feet, and I put a grid pattern, put a large nuclear weapon across everywhere on the surface of the Earth, every kilometer, and set them all as simultaneously. So whatever you think of as like a World War III, it's a million World War IIIs all happening within a second.
Jeez.
That's why it would, we're fairly certain that would end human civilization.
It's hard to even wrap your head around that.
Yeah, it's a lot of energy.
Um, John asked, what is the next telescope proposed for asteroid detection after the Vera Rubin telescope?
The next big one is one that NASA just approved building this week. It's a little over $1 billion, $1.2 billion, and they want to put an observatory into space, which will complement the Vera Rubin Observatory.
Oh, wow.
And it is to be launched in 2028. And so together with the Vera and Rubin Observatory, together, those things will probably get us to that 15% point.
Wow, amazing. And that's not that far away in 2028.
No, but again, we're really looking forward to 2024 with Vera Rubin.
Okay. Carrie asked, good question. Could the space junk orbiting around the Earth pose a risk to collide into the Earth?
Well, small pieces, but the energy is much, 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 much less. And so that space junk is an issue, but it's for satellites in space getting hit, not really for things on the ground. The risk to that, though, is that much of our infrastructure now goes through space. All of our navigation systems, GPS, a lot of our communication systems, and so on, they run through satellites now. So if you have a calamity in space, it can actually, let's say it takes out the internet. Well, then a lot of our services run through that, right?
Mm-hmm.
So it is a giant issue, but at that level, not like wiping people out, but maybe it disrupts our economy.
Got it.
Which can be pretty bad, right?
Right. Do you know if Mars is more or less prone to asteroid strikes than Earth?
I think it's roughly similar to the Earth. It's smaller than the Earth, has slower gravity, but it is closer to the asteroid belt. So, it does get hit on occasion. There are craters on Mars.
Mm-hmm.
And to give you an idea of how many craters there are on Earth, look at the moon. Okay. The difference between the moon and the Earth is, of course, that here we have an atmosphere and oceans and plate tectonics that erase almost every crater. But the Earth gets hit more often than the moon, and we're basically in the same neighborhood. We have stronger gravity, so we actually get hit more on a per area basis. So, the moon is basically, there are so many craters that it's craters on tops of craters, right?
That's a good point. Yeah.
And that the Earth has more. It's been hit more often than the moon.
I had a question about in the very beginning of your talk, you were talking about the area near the Great Lakes where they found all the iron and nickel.
Mm-hmm.
How did they know that came from an asteroid?
Oh, if you map the surface using seismic or gravimetry, it's called, which is where they measure the gravity field, you can actually see the crater now. It's a giant 100-mile round ring still.
Oh, wow. Okay.
Yeah. The mines are actually in a giant ring.
Well, that's a pretty good
100
indicator.
miles across. Yeah, it's a definite crater.
Oh, interesting. Stephen also had a question. I'm getting into the weeds with this question, but anyway, if an asteroid is successfully nudged off course ever so slightly, could it be that it may come back around on a new collision course with Earth eventually? I'm thinking about gravitational effects of our planet.
Stephen, you're hired. That is a great question because, in fact, yes. The new trajectory will actually still come close to the Earth on a regular basis. So you do have to think about which orbit you leave it in, which is one of the arguments for being able to fine tune your deflection so that you don't just delay the inevitable. So yes is the answer.
Actually, in speaking of the Asteroid Institute, were you, did you collaborate at all or consult on or whatnot with the NASA's mission with, what was the name? Didymos, I think. And
DART, yeah, the DART mission, yeah, we were, I guess, in the peanut gallery crowd that helped make that all happen. Because as it turns out that NASA did not have a lot of funding for doing any of this asteroid work before we really pushed the envelope. Myself and a couple of other astronauts, in particular, a guy named Rusty Schweikart, were, testifying in front of Congress, working on this, being a thorn in NASA's side for a while. And then, I think we're in large part responsible for the fact that they ever got the budget to do that.
Wow. That's great. Well, it was so funny. We scheduled this talk, I don't know, what, 6 months ago at least or something. And then I saw the whole, the video of what NASA did with that. And I thought, oh, this is perfect timing because now asteroids are sort of on top of everyone's mind. So
Yeah,
really
and
good timing.
And the secret for everyone here is that it will be much more so in about 2 years because when this new telescope turns on, again, we're going to discover far more asteroids than have ever been discovered before, roughly a factor of 10 increase in the discovery rate.
Mhm.
Currently, NASA and the European Space Agency each maintain a list of the asteroids that have a chance of hitting the Earth. It's about 1,500 asteroids. These are the ones that they can't rule out from hitting the Earth. That risk is going to get really big. So when occasionally you read in the news about an asteroid that has a chance of hitting the Earth, the frequency with which those warnings will be coming out will be up by about a factor of 10 starting in 2 years.
Just because we'll know more.
Because exactly. And so that's one of the reasons why what we are doing, I think, is so important. We really need to get a good handle on calculating these things and making that information available.
Absolutely. One person asked, will we ever have a tool with enough energy to deflect a 10-mile asteroid?
Yeah, it's not the energy, but it is the momentum.
Mhm.
But it is all about how much notice you can give, because the amount of momentum transfer needed to deflect something with, say, 5 decades notice is substantially, and by like more than an order of magnitude less than it is in the last few years. Okay, so the trick is to do it early, and that means better maps, better computation, better certainty on where things are. And it's like a friend of mine said, it's like a play on the 3 most important things in real estate are location, location, location. He said the 3 most important things for protecting the Earth from asteroids is find them early, and find them early.
Right. And then and I'm sorry, I don't know what this person means about this, but they said, serious question, what do you make of 99942 Apophis?
This is an asteroid that is, when it was first discovered, we realized that it had a chance of hitting the Earth. That's because it's coming so close to Earth that we couldn't rule it out. It's a pretty good sized asteroid, and it is going to come very close to the Earth in 2029 and come back again in 2036. It's in a 7-year resonance with Earth, which means every 7 years it comes by. But in 2029, it is passing. It'll be visible with a pair of binoculars. It's coming that close to Earth. We have tracked it well enough that we know it will not hit the Earth then, but it is coming very, very close, underneath many of our satellites that are orbiting the Earth. So it's going to be a good show, visible. Unfortunately, not from North America. You'll have to be in Europe to see it. It's on the 13th of, I think, February 2029, but it is a Friday the 13th, if I remember right.
That sounds
so yeah, it's real. It's coming back. It'll be an interesting thing to see.
Oh, wow. Okay, remember this name, Adrian Solorzano, says, Dr. Edlu, I've been following you since 2013. You and the Institute are my biggest inspiration. I hope to work alongside with you in a couple of years. I'm a Broward College student graduating this spring. So remember, when you see Adrian's resume come across your desk.
keep up the good work. That is awesome.
And then
and
John,
you know how to reach us.
Yeah. Don asked, how do you deflect an asteroid with disintegrating it?
Is that with or without? I'm guessing it means without disintegrating it. In fact, yes, you just want to change it. You just want to give it a nudge and change its trajectory by a small amount, really. So the idea is it is better to not break it up, because if you once you break it up, then it's a little hard to guess where the pieces are going to go. It's like if there's a car accident, I'm trying to figure out where every piece is going to go. I don't want to make sure that I don't want to get hit by any of the shrapnel, if you like. And even a shrapnel piece can be enormously, carry an enormous amount of energy.
Awesome. Oh, Carrie asked, Carrie, I saw I'm assuming your 12-year-old there. Do you have any suggestions on a beginner telescope for 12-year-olds? And Carrie, we get that question a lot. Unless Dr. Liu has an answer for you, I can give you some information, but I'll let you.
Yeah, I would first go visit your observatory, right? And try some of them out, right? Because you have quite a number of telescopes, it sounds like. There are ones that are a little simpler, but I would say this. Sometimes people think the telescope you want is the one with the most magnification. That is not true. What you really want, I think, for beginner telescopes is the one with the biggest eyepiece that allows you to see, tell me if you agree or not, but I find that having a really nice eyepiece that has a really large field of view makes for a much more enjoyable experience.
That's great. Yeah. And like I said, Carrie, I will put my email in the chat. You can email me, and I have, like I said, we get that question a lot. So I can give you
go visit the Ferguson Observatory and start there.
Perfect. I think that was all the questions. Oh, I wanted to ask, and I think I do know the answer to this, but I think a lot of people don't. Where does the name B612 come from?
For anyone here who's ever read The Little Prince, that is the name of the asteroid home of the Little Prince. That's where we got our inspiration from. So I just want to thank you all. And if you'd like to know more about our work, our website is b612foundation.org, b612foundation.org. And again, if anybody has the inkling to support our work, or the Ferguson Observatory, I can highly recommend that. Then, organizations like ours, we subsist on donations. We have to pay people, and we have to keep the lights on. And but sometimes it's these smaller organizations that I think have the most effect. So I would hope that you or somebody you might know, or at the very least, just tell people about the work that we're all doing. So thank you very much.
Absolutely. Thank you so much, Dr. Liu. It was really interesting and enjoyable, and very, very much appreciated. You can probably see in the chat lots of thank yous. And thank you for a great presentation, great talk. So I hope
thank you, everyone.
See all that. But thank you. Have a wonderful evening. And thank you again, Dr. Liu. Really appreciate it.
Take care.
All right. You too. Bye-bye.